And then we can move on to our to next speaker. That is Jean-Philippe Nominé from CEA. He is HPC Strategic Collaboration Manager at the CEA and also ATP for HPC Steering Board member and also Vice Chair for Research. Lot of titles.
Thank you so much, Daniele. Thank you so much. Now comes the dangerous moment of activating some screen sharing. So tell me whether this is fine.
Oof. Very fine.
Oof.
At the first attempt.
Oh, it's not so frequent. Okay. Good afternoon, everybody. First of all, thank you very much, Daniele, and the other organizer for the invitation to such a nice and rich event, and for the nice logistics and moderation too. Okay. For this welcome. Let's move forward for the last talk of this session. Back to some, I would say, less technical and scientific presentation. First, I would like to credit my colleague and friend Guillaume Colin-Verdière for co-authoring this presentation. In practice, Guillaume is the main contact point for us when it comes to HPC and quantum computing, and is principal investigator for this IMM more on the side of general management of European and international collaborations, but happy to work also on quantum aspects. First of all, let me quickly remind from where I'm speaking. CEA, Alternative Energies Atomic Energy Commission, is a large research and technological organization in France with 4 main areas of activities. Carbon-free energies, including more and more renewables, global security and defense, technological research for industry, and I would say some cross-cutting underlying fundamental research in universe and life sciences mostly. And for this all, we use a lot of HPC-enabled simulation, data analytics, and artificial intelligence. So not surprisingly, with time, we've developed activities all along the value chain of HPC, infrastructure, technologies, applications. For instance, we operate large-scale HPC facilities. I will show you afterwards briefly. We develop pieces of technology from I would say microelectronics, semiconductor components, up to software, system-level co-design with industrial partners, etc. And including also a lot of software from, I would say, all aspects of stacks, middleware, up to applications. And of course, we are, for all our missions and programs, a heavy user of HPC, together with many scientific and industrial partners. Okay. So this is for a general setting. When it comes to quantum research, a quick word, because we also have fundamental and technological research on, I would say, quantum elements that are useful for quantum computing. I would mention 3 teams, 3 main teams. We have some more, but you may know some of them. Historically, we have this Quantronics group in Saclay with Professor Estève, and still very active. In the early 2000s, he was a pioneer in supraconducting technologies for qubits, Josephson junctions and Cooper pairs in particular. And now they are developing new things which are quite fundamental on nuclear spin-based qubits, for instance. More recently, and growing and raising, we have the group of Nicolas Sangoire, Institut Physique Théorique, Saclay as well. I recommend you this very nice recent paper by Nicolas and colleagues on reflections on possible models, need of memory for quantum computing, not only computing resources, etc. And Nicolas will be involved in the project I will mention further on. And last, not least, we have in the Technological Research Directorate this time, Nominé and teams who work on CMOS qubit, silicon-based quantum computing, together with CNRS, University of Grenoble, and other institutes, of course, but Leti is more or less leading and coordinating this with, I would say, a number of nice either quantum flagship or ERC projects, and you have a few references and pointers here. Just to say, we have those people who are upfront, and when this feeds the maturation of technology, and when startup can then follow up on this and start developing products. We are very, very happy. And this contributes to the global, I would say, European momentum in quantum computing. And then when it comes to HPC by itself, we do operate those infrastructures in single sites. This is near Paris, south of Paris, Bruyères-le-Châtel. All the big supercomputers operated or owned by CEA are grouped here in 2 facilities. So we have big defense one, around 60 petaflops as of now, currently. We have the public research one together with GENCI. This is GENCI's Joliot-Curie machine, 20 plus petaflop currently. And we have also a third one, which is a separate, I would say, system and machine and room, machine room, meant for industrial use of HPC with industrial partners. And it's around 10 petaflops as of today. It's called CCRT, and I insist a little bit on this one because it's very original. We have a co-funded, actually, a co-funded computing center, mostly co-funded by industrial partners with around 20 private or semi-private or public-private partners, with a separate machine meant for industrial confidential use with specific access data management, etc. Because it's industrial production runs they do on this machine. And as early as 3 years ago, we installed a QLM for them, mostly for industrial partners, to have early access and to be able to investigate as early as possible use cases in quantum computing or hybrid HPC quantum computing. And this is a 31 qubit, not so recent QLM, but still up and running. Voilà, for the global picture. Now, let's come to our global vision and standpoint when it comes to HPC plus quantum computing. Alors, beginning of this year, this is politics, very briefly, but as a reminder for setting the stage, we had President Macron announcing a French plan in quantum computing, quantum technologies at large, including quantum computing, including a specific project called HPCQH. Okay, in short, that would mean hybrid quantum computing platform. And this is the project on which I will now focus a little bit more, because this is starting just now. I mean, these days, these weeks, after some preparation phases. So what is this project? It's meant to develop usage of collaborative quantum HPC computing. It's both to develop progressively a friendly environment for end users, plus a test bed for research. It is meant to be an agnostic platform, hybrid HPC quantum elements. The CEA TGCC center, the one for research and industry I just mentioned, is the reference center selected by France for this. It will be based on a quantum emulator or quantum emulation environments, mostly using Atos QLM or my QLM that were previously mentioned, and many of you know or use. We intend to install a diversity of QPUs progressively. Pascal, very likely the most mature one and interesting one currently in our idea, but also will come French or European technologies mostly. This will be aside or coupled or together with TGCC agency research supercomputers in our big open research center. And we want to develop elements of agnostic with respect to hardware, software, a diversity of the best breed software for users to develop algorithms and applications. For Axis, acquisition of QPUs, this will be done with GENCI, the National Agency for HPC for research equipment, with research, academic and industrial players to develop software and application, develop hybrid use cases, scientific and industrial ones, and of course, there will be also an activity of dissemination, training, developing skills and competencies. Okay, it's a 5-year program, 88 million, starting now, end of this year. First actions are being put in place right now. So CEA, INRIA, GENCI are leading the different tracks together with other public or private actors. And our first, I would say, concrete action is coupling this with EuroHPC HPCQS project, which just started, was kicked off a few days ago. I would say a few more words, but probably later on in the afternoon, Christian Michelson will explain you HPCQS more in detail with a Yulich standpoint. And for us, this is the first step of this program. We combine it with HPCQS, but more will come. Combine as well as much as possible with future efforts supported and co-funded by EuroHPC in the coming years. For CEA, for any further question discussion, we can put you in touch with the main contact point on this. For us, it's Jacques-Charles Lafaucrière, our HPC program director at CEA. In short, we will work in the research environment together with GENSI in our TGCC center, and we will start with a combined French, European effort, a multi-country effort through HPCQS, EuroHPC project, 6 countries involved in this project. A word on the regional level, we are leveraging this as well because Île-de-France, Paris region, Paris greater metropolitan area, if you will, is very dense in terms of scientific and technological activities. So it's a very good place where, with many labs and industrials to put people and actions together. So we have a number of local initiatives for this. The one called PAC Quantique, supposed to support industrial in the use case exploration together with academic partners and directly working with the technologies developed by quantum startups. This is supported by the region. TerraTech is another association born in our region, but with now a national and even European dimension, but they have a strong club of very large advanced industrial users. So putting that all together is virtuous. It helps connect local levels with more global, national, European levels, and combining efforts. You have pointers if you want to learn more about those initiatives. So the first technology of interest for us is clearly, as a first step, we want to endeavor Pascal, with whom we've been in touch for a while already. There was a very nice talk by Sébastien this morning, so no need to repeat everything. I would insist on a couple of things. I saw this rather confidential and discreet announcement a few days ago related to a Q quantum event and on LinkedIn, some announcements that Pascal, together with their usual research partners, Institut d'Optique, etc., reached 500 qubits in the lab, which is extremely nice and promising. And in the meantime, and in parallel, they are developing their product. They are productizing their technology. On the left, you have the lab machine we know well. And on the right, you have the mock-up of the future product. This morning, Sébastien, if I am not wrong, even showed a real picture of the real industrial prototypes. They are moving ahead very nicely in engineering and industrializing their prototype, and we are very, very impatient to see that and possibly install and deploy that. Voilà. And last part would be a quick overview of our role in this HPCQS project. Like I said, kicked off on December 1st. It's a EuroHPC project, so-called pilot quantum simulation project from Work Program 2020 of EuroHPC, where it took some time to put all in place, grant agreement, etc., co-funding. But now we are ramping up and starting for real. So very quickly, we have 6 countries in this project: France, Germany, Spain, Italy, and Ireland. You see the partners here. The idea of HPCQS, supported by EuroHPC, is to set up the foundations of a hybrid quantum HPC infrastructure, starting with a dual installation of systems, one in Jülich, supercomputing center, one at CEA together with GENSI. So in 22, we will start with, I would say, installing, deploying, or complementing emulation environments, mostly based on QLM, for people on applications to be able to start studying algorithms, workflows, etc. And then in 23, we would install 2 systems, which would be procured in the meantime, one at Jülich, one at CEA, and similar systems. And we want to develop together software stacks, elements, user interfaces, tools, etc. And that would really be for us the spearhead. We want to further share in the future of a pan-European infrastructure for quantum and HPC. Our mission in this project, CEA in particular, is twofold. We will be one of the two sites integrating, deploying, like I said, emulation environment, then the real quantum system, the quantum simulation system. For us, it will be TGCC aside, coupled to Joliot-Curie Tier 0 system, Gen6 research machine. And we have Nicolas Angoire's team in EPHT, which will develop a number of things regarding benchmarks and applications. So on computing center side, that is my side, we will have some coordination, technology watch, infrastructure, integration, system related issues, operations teams will be involved, etc. Main contact is again Guillaume Colin-Verdière, and I'm proxy on this project. So don't hesitate to have any time to talk with you if you're interested. And on the application benchmark side, that will be Nicolas Angoire's team working on that. And to give you a flavor, a teaser, because we will need another workshop in the future for the real experts to comment their developments. The CEA people will work on 3 of the use cases identified in HPCQS. First, it will be on certification and performance analysis. Roughly speaking, it will be about certifying quantum properties and accurately evaluating performance of quantum systems. And this will be together with CNRS, developing that witness-based, device-independent, analog randomized benchmarking, this kind of stuff. And Nicolas Angoire is really a well-known expert in these areas in particular. Then there will be an activity on QA/OA. In particular, CEA will study, other partners will contribute to these activities, but CEA will particularly focus on factorization applications. And the last one will be in VQE. Then on this, CEA will work more particularly on catalysts for nitrogen fixation, which is a very promising potential killer application for quantum computing and HPC plus quantum computing. Beyond using the machines for the partners for these use cases, the project, HPCQS, intends to open resources as much as possible to the wider European communities as soon as possible, and when we set up the platforms. Voilà, to finish with some teaser and advertisement. On our side, together with TerraTech, we've been organizing workshops as well since years. This is within the scope of so-called TerraTech Forum, which is a two-day event traditionally taking place in June in France, which is becoming more and more international. We started quantum workshops in 18 with some I would say prequels as soon as 16. Last year we had a nice one together with Christel Michielsen on hybrid computing, and in 22 we intend to come back to technologies and do an updated tour of European qubit technology. So as a teaser, we started talking, or we would like to invite a number of European companies. So Guillaume and I will take care of that, and some of you may hear from us soon, so as to try to organize a workshop, and everybody will be welcome. It's open, free registration, etc. So hope to see some, or if not most of you, next June. Hopefully face to face, but well, we'll see. And last advertisement would be, I would recommend the reading of this nice paper we wrote from within ETP for HPC with a bunch of friends and colleagues. Some of them, if not most of them, I think are in this session today, like Daniele, like Michael from CSC, like Christel, etc. And that's all for me. Thank you for your attention.
Thank you, Jean-Philippe. Very interesting talk, and glad that you spoke also about HPCQS and our white paper for ATP for HPC. That it was a pleasure to participate in both of the projects that you mentioned. And of course, we will help you also on the side of the use cases and on other things that you will need. So, is there any question for Jean-Philippe? Don't be shy.
No, I was a bit. I prefer to be. It's always better to be shorter than longer. So I was maybe a quick, fast. What I can say, I was not too technical. First, I'm not the best expert in many of these areas. So next time, maybe some real experts could be speakers to give better insights on their progress. But I can tell I really appreciated a lot a number of things I saw in previous presentations, in particular from Elerset and from Luigi and from Sarah from Ariana, because when it came to discussing coupling modes, workflows, how to associate, combine classical HPC, quantum HPC, I really appreciated what they showed. It is very interesting, and this is exactly the same kind of questions and reflections we have or want to have. And I think we must really foster further discussions, exchanges all together, because this has to be really a collective effort, and we have to. We already share a lot of ideas, and we have to more practically share, I would say, efforts and actions on these topics.
Yes, I agree. So, okay, we have some question here in chat.
Yes.
We can read the first one, the second one, because the first one is only it's not a question. So please, Fabio, brought your question. And the question is, what are the main universities France involved in quantum computing?
Yes.
You mentioned Grenoble, but there are any other?
Okay, when it comes right, quantum at large, we have strong teams. I mentioned Grenoble University because they are partners of our LETI colleagues and Institut Néel in Grenoble. So this is clearly to be mentioned. And I would say a very strong team is with École Normale Supérieure, Laboratoire Kassler-Brossman, LKB in Paris. But it's from fundamental physics and now up to quantum computing. It's broader. You know, École Normale Supérieure, they have the Nobel Prizes. They have Cohen-Tanouji and Haroche. Okay, but this is the fundamentals of quantum physics that made possible our discussion today. Without these people, we wouldn't have today the capacity to consider the manufacturing of qubits. Though we really need this fundamental research. So there is a strong activity around École Normale Supérieure, but universities in Paris are also involved. Can be Paris-Saclay, the group of universities around Paris-Saclay has different teams working on that. And and then you have a strong group around. It's a mix of university and engineer schools in France. We have a quite particular system. We have a very strong group around Institut d'Optique in Palaiseau, which is not far from Saclay, not far from Paris, but it's still a bit different. Pascal is coming from these teams, Institut d'Optique. This is an optics engineering school. They are extremely strong in optics and now quantum computing. And from this Saclay, Palaiseau region, you have Pascal coming, you have Candela startup and more. And from École Normale Supérieure, you have Alice and Bob startup. This shows this is very vivid. And I will eventually mention École Polytechnique nearby. They also have good people, and they are very good education and training in quantum physics and quantum computing, to name a few.
Very good, thank you. And we have another question. So it says, I see that many initiatives, with some notable exceptions, are at regional and national level. What is your opinion about the perspective at the European Union level, also for the Euro HPC commitment?
We need to pull efforts. It's not so easy. My hope, we've observed that in HPC, conventional HPC, I've been working that for 15 years, so I know a little bit the issues and what was improved or not over the last 15 years. It was quite difficult and still to align and pull efforts. In quantum computing, we desperately need to align some efforts and pool efforts. I am a bit more, it might be a bit easier because it's a new area. We don't have too many legacy issues or problems or background to handle. The history is a bit new. We write more or less a new page, a blank page. So I'm a bit more optimistic that we can, thanks to good research by the quantum flagship, part of it leading to startups developing qubits. Now your HPC pushing efforts on quantum equipment and hopefully related software. I think we have good ingredients. We need not be already 100% all agreeing on everything, but we have good chances that with quantum flagships efforts, some articulation of your HPC, we have good chances to really leverage a number of national initiatives, assets, talents in different European countries and maintain a diversity of effort. I think it's a domain that still needs to remain very open, exploring a number of options, because nobody can tell in 2, 5, 10 years what will work, what will have survived. And we are in a good position in Europe. We should really be aware that we need to work all together. And we probably can find enough sufficient common ground to work together positively.
Okay. Thank you for your answer. And okay. Also, Fabio, thanks to you. If there are no other questions, I think that we can thank everybody, Jean-Philippe, and then we can anticipate the 5 minutes of our break. And I think that can be a good idea. And we will restart at 15:30. So thank you a lot, Jean-Philippe. It was a very nice talk. See you in another occasion. Thanks.
Yeah, hopefully.
See you, everybody, at 15:30.